Hello everyone, welcome back. In previous lecture, I explained about the various decision making criterias, and in today's lecture, I will start with the decision making under conditions of risk. In previous section, the decision making was carried out under the conditions of uncertainty, as well as there was not specific knowledge about the probability of occurrence of the event, where there is possible to allocate probability to any event of occurrence. The decision making is done under the conditions of risk. So here a decision maker knows the probability of each and every event which is going to happen. Calculated risk is taken by him. Under the conditions of risk, two most popular criteria for finalizing alternative is the expected monetary value, that is EMV, and second one is the expected opportunity loss, EMV, and expected opportunity loss, that is EOL. Both criteria, EMV and EOL, the produces the same optimal decision alternative. EMV is based on the either the largest EMV or the smallest EMV, depending on the maximization or minimization. Same way, EOL is based on finding out the minimum EOL value irrespective of whether problem is of maximization or minimization. First thing is decision making under condition of risk is expected monetary value. Now there are certain procedure for calculating the EMV for given data, in which the step number 1 is to develop a conditional payoff matrix. First one is conditional payoff matrix, listing the alternative decisions and various state of in which there are alternative decisions and the state of nature is listed. Second thing is to determine the conditional profit for each decision event combination along with the associated probability. Find out the conditional profit for each decision event combination along with the associated probabilities. Third step is calculate the EMV for each decision alternative by multiplying conditional profit by assigned probabilities and by adding the resulting conditional values. What we do for each decision alternative? By multiplying conditional profit by assigned probability, we multiply EMV is calculated by conditional profit into the assigned probability plus a resulting conditional value, whatever the conditional value. and the last step is to select the alternative that gives the highest EMV. Now let us take one example. Here following are the records of demand of an item for the past 1 month. Demand in unit and probability is given. Calculate expected demand, and the item cost price for of an item is rupees 25 and selling price is rupees 30. If at the end of the day any surplus has to disposed at rupees 20 per item, what is the optimum output? So here the cost price is 25 rupees, sorry, and selling price is 30. So profit is equal to 5 rupees. Now unsold disposal price, unsold disposal, if it is not sold, so we get only 20 per item. So loss for unsold item, that is also 5 rupees, because the cost is 25, and if it is not sold, so it will be unsold at 20, we will have loss of 5 rupees, and if we sell we will get profit of 5. So conditional profit is equal to 5 times D if capital D is greater than the selling price, if the demand is very greater than or equal to selling price. So here if we take the 5D minus 5 into selling price minus demand, which is equal to 10 times the demand minus 5 times the selling price if the demand is less than the selling price. These are the two criteria. If demand is greater than or equal to selling price, it will be 5 times D, and if the demand is less than the selling price, it will be 10D minus 5S. Now preparing the conditional profit table. For preparing conditional profit table, let's say that the production is of 100 units and demand is also of 100 units. So as calculated above, profit per unit is rupees 5. So total profit will come rupees 500. Now for production of 100 units, even if demand is increased above 100 units, profit is fixed for 500, and if the production is of 110 units, then the profit for 110 units and above 110 will remain 550 will the same. Here this is the table, the production and demand are same. So if we produce 100 units and the demand is of 100, so we will have the probability, we will have the, according to probability, we will have the profit is equal to 500. If we, the profit is demand into 5, profit is 5, demand D. But if here the demand is 100 unit and demand is 100 unit, 110 unit, and if we produce only 100 units, so we will be having loss of 10 units. So here also the profit will be 500 because we didn't fulfill the 10 demand, so the profit will be remains fixed. We cannot get the 550 because we produced only 100 units. Similarly, the profit will be fixed if the demand, whether the demand is increasing but our production is fixed, so we will get a fixed amount of profit. Same way, if even if the demand is of 140 unit and our production is 100 unit, then also the profit will be fixed. Same way, if we take that the production is of 110, so what will happen? We will have a loss of 50 units. So sorry, 10 units, because 10 units we produce extra, so we will have to pardon the loss. So we will have to bear the loss. So the profit at demand is for 100 demand, the profit is 500, but we sell, but we the unsold product will be 10 and we will have the loss of 5 per unit. So 5 into 10, so will be 50 loss. So subtracting from that, we will get 450. But if the demand is 110, then we will get the 550 as a profit, and that will remain same even if the demand is increased. Our production only limited to 110, so the maximum profit we can get is 550. Similarly, we calculate for each and every production rate, and according to that we calculate the demand and our profit for various production rate. If we produce 140 product and the demand is only 100, then we will be having huge loss. Here you can see, but if the demand is 140, we can get the maximum amount of profit. Now next thing which we have to do is to preparing the expected profit table. So for preparing the expected profit table, we multiply the probability with this profit. So here 0.05 into 500, it will be 25. Same way, for each and every we multiply probability with the profit. So similarly we will get these values, and after sum of these we will get the expected total profit. So for first 100 production, the expected total profit is 500. 110 unit, it is 545. 120, it is 565. For 130, it is 545, and 140, the 499. Because we know the probability, so now from the expected total profit, here the optimum number of item produced will be 120, because the expected profit is maximum at this 565, that is the EMV, expected monetary value. So this is how we calculate the EMV. Next is EOL. For EOL, expected opportunity loss is alternative criteria for decision making under risk. EOL is defined as the difference between the highest payoff and the actual profit due to choosing a particular course of action in particular state of nature. Hence, EOL, expected opportunity loss, is the amount of payoff that is lost by not selecting a course of action, resulting to minimum payoff in particular state of nature. So the procedure for calculating EOL, similarly there are 4 steps. First we prepare the payoff matrix for alternative decision. Second, we determine the conditional opportunity loss by subtracting the payoff from the maximum payoff for that event for each decision event. Next, combination along with the associated probability. Third thing which we are supposed to do is to calculate the EOL for each decision alternative by multiplying the conditional profit by assigned probabilities and adding the resulting conditional values. So the second step is determine the conditional opportunity loss by subtracting payoff from the maximum payoff, then calculate EOL for each decision alternative, and last alternative given the highest EOL. Similarly, the same example as previous we are going to take, and the profit will be the 5 and loss will be 5. We will prepare first the conditional table. So this is the complete table, and here the conditional table will be the same. As the conditional table for the previous was the same, the conditional loss table will be, we have to calculate the, instead of here there will be, for if we have a production of 100 units and demand is 100, the loss will be 0. If the production is 110, loss will be 50. Here it will be 100, 150 and 200. Similarly, we calculate the all the losses. As you can see, the demand is equal to the, if the demand is equal to the production, we will have 0 loss. But if it is more or less, we will be expecting loss. Now for preparing the expected loss table, we multiply with the probability as we done in the previous. Multiply this probability with this value. So here it will be 0.25 into 50, it will be 12.5. Similarly, we calculate the sum of this vertical row, that is the our total expected opportunity loss for each production rate. Now you can see that the optimum number of item is here also, it is 120 unit, because the expected opportunity loss is minimum for this value. So this is how we use these two models. Next is expected value of perfect information. In previous examples, the occurrence of status of nature was associated with the probability. If the complete and accurate information about the future demand is available, then it is possible to stock the same and hence the maximum profit can be gained. So the expected profit when the perfect information is available is termed as EPPI, expected profit under perfect information. EPPI, expected profit under perfect information. It is nothing but the sum of when the demand and the supply are same, which leads to maximum profit. The difference between EPPI and EMV, that is expected monetary value, it is our EVPI, that is the expected value of perfect information. Same way, if the EOL model is there, so EOL minus EPPI is equal to EVPI, expected value for perfect information. Now let us take the same example. We prepare the expected profit table. So the profit table here you can see, as we prepared from the EOL model, the EMV model, the expected profit we prepared in the previous example. So here the EMV is 565, as we know that the 565 is the EMV value. Now preparing the expected profit under perfect information. So expected profit under perfect information, that we have the information that the demand is equal to production, that this will be the fix. So the profit will be, the table will look like this, that we will be producing this amount of units only, you can see, because we are having the perfect information. So expected profit under perfect information will be the sum of these values, because we didn't need the probability, because we have the perfect information that there will be 100 demand, or there will be whether 110, or there will be 120, 130 or 140, whatever the demand, we will know the production rate. So the EVPI is calculated by EPPI minus the EMV. So the cost for perfect information will be, EMV is 565, so 599.5 minus EMV, it is equal to the EPPI. That EPPI means the EVPI, the EPPI is equal to 599.5 minus the expected profit, here it is EMV is 565. So our EVPI, expected value for perfect information, will be 34.5. So this is how we calculate expected value of perfect information. Our next topic is about the decision tree. So in previous problem, decision was taken for fixed period of time, payoffs and the state of nature course of action, then the probability associated with the occurrence of state of nature were not subjected to change with the time. However, the situation may arise when a demand decision maker has to receive the previous decision due to change in the predicted situation, or arise of any unexpected situation which may be favorable or unfavorable. Such kind of situation, when it is required to change the decision, is called as sequential decision process. For this kind of sequential process, we develop decision tree. A decision tree consists of nodes, branches, probability estimates and payoffs. So there are two types of nodes. First one is the decision node, and second one is the chance node. A decision node is represented by the square, which represent a point of time where a decision maker must select one of the alternate course of action among the available solutions. So the course of action are shown as the branches of this, the course of solution, and the chance node is represented by the circle, and which indicate a point of time where the decision maker will discover the response to his decision, and each course of action result into the chance nodes. Second thing is the branches. Branches emerges from the connect various nodes and represent either decision or state of nature. There are three types of branches. First one is the decision branch. Second one is the chance branch, and the third one is the terminal branch. Decision branch is branch leading away from a chance node and represent the state of nature of a set of chances events, while the decision branch is the decision node represent a course of action that can be chosen at decision point, while the chance branch leading represents the chance node and represents the state of nature of a set of chance event. On the other hand, the terminal branch is the branch that makes the end of the decision tree, and terminal points of a decision tree are supported by mutually exclusive points, so that the exactly one course of action will be chosen. And the last thing is probability estimation. It is the estimated probability of each chance event. And another thing, that is payoff can be positive or negative. It can be associated either with the decision or the chance branch. So here this is the how the decision nodes, decision branch and chance node will look like, and we will be having P or Q, that is the state of nature, and we will have the result as positive or negative, that will be the payoff. So this is how a decision tree looks like. The procedure of solving decision tree is that the optimal sequence of decision in a tree is found by starting at right hand side and rolling backward. At the each node, an expected result is calculated, and this return represents the return at the particular position, which is termed as positive value. If the node is a chance node, then the positive value is calculated as the sum of products of the probability or the branches from the chance node and their representative position value. If the node is decision node, then the expected return is calculated from the each of its branches and the highest return is selected. This procedure is represented till the initial node is reached, and at initial node the positional value represents the maximum expected return obtained from the decision sequence. Now let us take one example. Here there is one job contractor who wants to decide whether the contract for job should be taken or not based on the following estimates. There is a decision given: accept the order or not to accept, and the probability is half, which means 50%, 0.5. There are three outcomes. If the accepted order, the probability of outgoing outcome, then the payoff value for the same, and if the not accepted, then what will be the probability of outcome for given demand and the payoff value. Now we have to construct and evaluate the decision tree diagram for this. Here the decision tree for this problem is shown over here. We will start this is the complete decision tree. First, if what if we accept and what if we not accept, and what will be the value here. There is the probability over here written as shown in figure. At each chance node, payoff is calculated. So here there is each chance node, the payoff will be calculated. So for first, this is the payoff will be calculated, the probability into the payoff and the expected payoff is calculated for each and every chance node. And further, the expected payoff at each chance node is produced of payoff and probability of chance event, which is shown in the figure. Now the total expected payoff at each decision node is the summation of expected payoff at each chance node. So here the first decision node, the expected payoff will be 1925, and where the second decision node, the expected payoff will be 1887.5. So the contractor should accept the job. So this is how it is calculated. This is the first probability into multiply second probability. We will get the total probability for each node, and the payoff is given in the given data. So we will calculate the accepted payoff, and we will sum for the first node and sum for the second node. So we can decide whether to accept or not. So here the accepted payoff is high, so he can accept the order. So this is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.